Hello viewers, this is Mr. Odingo and I want to welcome you to this lesson of today, that is Geometric Series. If you have been following our lessons, you realize that in the previous parts of this topic, that is arithmetic progression, arithmetic series, and geometric progression was taught by Madam Violet, but is not in. I will be able to come in and be able to continue from where she left. That was geometric series, was supposed to be the next part to be taught. Now, geometric series, as have been explained here, is the sum of terms of a geometric sequence. If you know what a geometric sequence, it is just terms, like in this case, terms that form certain pattern. In this case, 3, 6, 12, 24. This is a sequence. But when we add these terms, then we change from a sequence to a series. So if I add 3 plus 6 plus 12 plus 24, I end up with a geometric series. So this geometric series, we are going to look at the formulas that you can use to be able to get the sum of the terms in a geometric sequence, or what we are referring to as a geometric series. And with me here, you see I've indicated two formulas. One of them is when r is more than 1, and another one when r is less than 1. So those formulas must be different, and you must be able to choose where do you use formula 1 and when do you use formula 2. If I give you example, like in this case, I have 3, 6, 12, 24, or if I have 64, 32, 16, 8, and so on, you realize that this series 1, this series 1 here, the numbers of this sequence are increasing. But if you look at here, these ones are decreasing. Let me give plus so that they become a sequence. Now, if you have this particular series, you realize that for you to get r here, it will be r equals to the common difference, that is 6 over 3, that is 2, or 12 over 6, 2. It must be common. But if you come to the second one, the ratio here will be 32 divided by 64, which is likely to be a half. So you realize that in the first series here, the ratio is 2, which is greater than 1. But in the second one, the ratio is a half. So if you have a sequence where the ratio, common ratio, is less than 1, like in our case, the second one here, and in that case, you'll find that the numbers are decreasing, like in this case, 64, 32, 16, 18. In that case, you have to use the second formula, where r is less than 1. But if you get a series where the terms are increasing, like in our case here, the ratio is 2, 2 is greater than 1, you need to use the first formula here. Now, you realize that I've mentioned here that in these both formulas, Sn is the sum of n terms. N could be any number, could be 10, 12, 15. A is the first term of the series, and r is the common ratio. Now, you realize in the both series, r can never be 1. If r is 1, it means that the first term and the second term are the same. Probably if you have 10, 10. In that case, that's when you're going to have 1. So it means that that's not actually a series. So we are saying that, and you realize that if r is equals to 1, we are saying here r must not be 1 in both of the formulas. If r is 1, let us try here. 1 power n will just be 1. Minus 1 is 0. 0 times a is 0. Everything falls back to 0. So we cannot, r must not be 1 in this particular case. And we know that if r is 1, then that's not actually a sequence. Those are actually the same number. So let us go forward to look at example 1. And in this case, where r is, when r is more than 1. So let's have examples. Plus, here, let's say 10 terms. So we are having this series that is continuing up to the 10 terms. So actually, we are supposed to get the sum of the following geometric series. For the part A, we need to get 3, 6, 12, 24 plus. You add numbers like that until you reach the 10th term. So the sum of the first 10 terms of this geometric series, the first thing we know that we have to get r, the common r, and r here is supposed to be the next number divided by the previous one. In this case, 6 divided by 3. That one can also be the same as 12 divided by 6, or it can also be 24 divided by 12. So you realize that if you divide, you can take this over this, or this one divided by this, or this one divided by this. You realize that those answers are the same. 6 over 3 is 2. This one is 2. This one is also 2. So R here equals 2. Remember that you don't have to divide what I've divided here. After you identify that this is a geometric series, you just have to divide 1 to get the common ratio. So because the common ratio here is more than 1, then we need to bring in the formula which we said sum of, now we have 10 terms. We know that the formula is sum of n terms equals to a into r power n minus 1 over r minus 1. But this is the formula, but now we know we have 10 terms. So where n is, we put 10, that is sum of 10 terms will be, our first term is 3, a is 3, into r, our r is 2. 2 power 10 minus 1, everything divided by r is 2 minus 1. So this one, if we continue with the workings, what will we get here? Let's say 10 to, let's go to your calculator. 2 power 10, 2 power 10, 2 power 10 is 1024. So I have here, sum of 10 terms will be 3 into 1024 minus 1 over 2 minus 1 is just 1. So sum of 10 terms will be 1024 minus 1 is 1023, then times 3. We are going to have 69. So the sum of the first 10 terms of this particular series is 69. Now let's move to another question. So again, if this geometric series is moving up to 10 terms, we know that the first term here is a. The a is 64. R here should be 32 divided by 64, which again will be a half. Now because the ratio is less than 1, we are going to use the formula Sn equals to 1 minus, or a, into 1 minus r power n over 1 minus r. In this case, S10 will be, our a is 64, into 1 minus r, where r is a half, so 2 is going to be a half, power 10 divided by 1 minus a half. So if we continue here, we are going to have 64 power 10 is actually 1 minus 1 over 10, 24, raised to power a half, because 1 minus a half is a half. So we'll have here 64. If you solve this problem here, you realize that 1 minus 1 over 10, 64 is that 1024 times 64. So we are going to have 63.9375 divided by a half. 0.5 here. 0.5, we have 127.875. That is going to be the sum of the first 10 terms of this particular geometric series. So viewers, you see how you have applied this concept here. For our first question here, r was more than 1, and we have applied this formula 1. When we come to this question here, r was less than 1, and we have applied this particular formula. So that's something you have to really know. No one will tell you which formula to use, but it is you to tell. Is the r is the guiding, the pointer here. If it is more than 1, the formula is this. If it's less than 1, the formula is this. I want us to go to the next example. They want us to get for 10 terms. 10 terms. Again, in this case, the first thing we know that a is 2, r here will be 6 divided by 2, which is 3. So again, you realize that in this case, r is more than 1. So we are going to use formula 1, which was Sn equals to a into r power n minus 1 over r minus 1. And in this case, we are going to have our Sn, n is 10. So we'll have a, which is 2, into r is 3. So 3 power 10 minus 1 over 3 minus 1. So what is 3 power 10? 3 power 10 is around 59. So we are going to have 2 into 59, 049 minus 1 over 3 minus 1 is 2. So you realize that this 2 and this 2 can cancel. So we can just have a 59, 049 minus 1 is going to be 59, 048 as our sum plus 1. So in this case here, we actually have to get the sum of the terms, but remember we don't know how many terms are here, because up to here you see there's a dummy here to show that some numbers are there. So first of all, we have to determine the value of n. After getting the value of n, then we can then move forward. But for now, we can be able to determine r, and we know that in this case a is 1024. R is the next number, which is negative 512. Negative 512 divided by 1024. This will give us negative half. So common ratio is negative half. A is that. So we know that this common ratio here is negative half. So if it's negative half, what formula will we be able to use? We are going to go for a formula where we know that this is more than 1, so less than 1 is here. So we are going to say, we are going to apply the nth term first for us to be able to get the value of n. And you know the nth term of a series is the nth term, n equals to unknown term equals to a r power n minus 1. That's the formula for the nth term from the previous geometric progression. Now that nth term is 1 here. So I'll just say 1 equals a is 1024 power times r, and our r here is negative half power n minus 1. So we want to be able to use this one to get the value of n. For us to use this one to get the value of n, what we are going to do first is to bring in 1024 here. So I can reverse by dividing everything by 1024. Now let me not divide by 1024, but divide by this. If I divide by negative half, power n minus 1 divided by negative half power n minus 1, I'll remove this one from this other side. So if I have this one divided by this, what I'm going to do, that you know that if you take this one, these are indices, if you get the reciprocal of this one and this power will change the sign. So I'll say negative half here, where we have now negative n minus 1, we will get 1024. That rule I think we use from the indices. When we are starting the book, we know we talked about those kind of concepts. So now that we have this one, but we have to know another concept in indices which says that if I get the reciprocal of this one here, the sign again will change. So if I get 2, if I reverse this one here, I get the reciprocal of this number, the sign here changes. So I can say again, negative 2 over 1 power, now again it becomes n minus 1, I'll get 1024. Those are rules of indices. If you know them, you can be able to apply them. So I'll get negative 2 let me say negative 2, yes, n minus 1 equals to 10, 24. So that one is what we have. Now, we can be able to break this into two. If you have negative 1 times this, I can say I have negative 1 power n minus 1 times negative 2 power n minus 1 equals to 10, 24. I'm breaking this thing to ensure that if I take negative here, this one becomes positive, because I'm trying to break a number. A negative 2 is the same as negative 1 times 2. That's what I'm trying to do here. So if I do that with this particular equation here, and I know that for this number to be positive, this one here must be positive. I know sometimes it's very hard to understand, but we know that any number, any negative number raised to power an even number will be positive. So we are praying that the value n minus 1 here obviously will be positive in the final answer that we are going to get. That is something that we really expect. I know sometimes we say if it's negative, how does it change to positive? But the question, if I have negative 1 power 2, I will get positive 1. But if I have negative 1 power 3, I will get negative 1. So what we are praying is that the power n minus 1 must be even number for this one here to be positive. So we can say that negative 1 power n minus 1 must be positive. Must be positive. And if it is positive, then we expect that any negative 1 power any number, you're going to get positive 1. Positive times this one, it will just be 2 power n minus 1 equals to 10, 24. So again, when I reach that particular point there, I can get n by applying logarithms, or I can just use any number raised to power 12. So I'll say 2 power 10. 2 power 10 is 1024, yes. So I'll say 2 power n minus 1 equals to 2 power 10. And then I'll say n minus 1 equals to 10, and n is 11. You see that actually we are right that n minus 1 is 10, and n is an even number. So if you take negative 1 power 10, you are going to get actually 1. So that is something that is very key. Now we have got the number of terms from 1024 to 1 here as 11 terms. So we are going to get the sum of 11 terms. But the sum of these 11 terms, we know that r is less than 1. So we are going to use the formula Sn equals a into 1 minus r power n over 1 minus r. So that's what we are going to have. Let me get some space up here so that we see what we are going to have. So that will be Sn, and in this case our n is 11. That will be equal to a we have 1024 into 1 minus r, and r is negative a half power 11 divided by 1 minus r, and r is negative a half. So this will be S11 will be, let me see, a half, negative a half, negative a half power 11 is actually 1024 into 1 minus negative 1 over 2048. Everything divided by, this is going to be 1 and a half. 1 minus a half is 1 plus a half, which is going to be 3 over 2. So what we are going to have here is that 1 minus answer, let me change into improper fraction, that's 1024 times 2049 divided by 2048. Also after that we divide this one by 1.5 there. So I'll say times 1024, then everything divided by 1.5, I'll say the answer is 683. That is the sum of this particular terms. So viewers, let's go to the final example, which is example 3. So viewers, we have a term here, we have a geometric series here, and we are told to find the least value of n such that the sum of the terms, if you have 1 plus 2 plus 3 plus 4 plus 8 plus that plus that plus that, we don't know how many times, to the number of n terms. When these terms become n, that number exceeds the least value to exceed. We know that there could be many values exceeding this one, but the least one, the first one to exceed, what will it be? So the first thing we are going to do in this particular case here, we want to get n. That's what we are looking for. So when we are getting n, the first thing we have to do is, if I have r, a I know is 1 here, r is going to be 2 over 1, which is 2. So if I'm getting the sum here, I use the sum for the formula Sn equals to a into r power n minus 1 over r minus 1. The reason is that we said that this formula we use when r is more than 1, and in this case r is 2. Okay, so what we have been told here, the word is exceed. Exceeding meaning that the first value to exceed that one, so not actually equal to this one. So the sum of this n to be more than 2 million. 2 million here. So what we are going to say that this term here, where is the value? A is 1. So we are going to say A1 is 1 into R is 2 power n, and we don't know that n, minus 1 over R in this case is 2 minus 1 should be more than 20 or 2 million. So more than 2 million or exceeds 2 million we want to see. Now we know that if you open this bracket, everything is just 2 power n minus 1 over 1, because this one is over 1. So over 1 here will be exceeding 2 million. So 2 million here. So if you have this one divided by 1 is just that. So we'll say 2 power n minus 1 should give us more than 2 million, slightly more than 2 million. Now we can take 1 the other side. So we'll get 2 power n equals 2 million and 1. 2 million and 1. Now when we reach this particular point here, the only thing is to apply logarithms. So we can say the log of 2 power n is equals to the log of 2 million and 1. So this one, bring here n, log 2 is equals to log 2 million and 1. So everything divided by log 2, everything divided by logarithm of 2. N here will be, we are using greater, so let me forgive that mistake. So this will be, n will be greater than, so logarithm of 2 million and 1 divided by the logarithm of 2. You get 20.93. So n should be greater than 20.93, but you know the value of n must always be all numbers. So the next number after 20.93 should be 21. So we can say n here is actually 21. So if you try getting the sum of this geometric series here, you realize that when you put 21 terms, you are going to find 1 million and something, probably 1 million and 2 or 1 million 1 or 1 million 3. That is what we need to get here. So the first term to exceed 2 million will be n equals to 21 according to this series. So that's the end of our lesson on geometric series. Viewers, please subscribe to our channel so that you can support us in this endeavor of teaching people during the coronavirus crisis. Thank you very much.